Yo, 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 let's start this shit. Good morning, Cooler SK and Harukanen. Hope this Wednesday is treating you well. YouTube Mena Pro sucks about the course that cost, but hope you got the money back at least. And Derek.net, who love these streams. Impressive schedule, Robin. Appreciate it. Appreciate you dropping by. Yeah, I try to keep this discipline going, streaming at least for a couple of hours each weekday at 9 a.m. local time, and so far it's going pretty good. Okay, yesterday was spent mostly on cleaning up, converting a lot of notes in the code into tasks in the issue and such, but I still think it was pretty good progress. And I think like we have working terraforming in place. We don't have any runtime errors at least, but we have one small problem with the terraforming. Emena Pro, yeah, I got a refund. Oh, that's good to hear at least. But I mean, like, internet is amazing. You can find so many amazing good resources. Like, if you want to learn programming, for instance, I think MIT has some courses online. Like, that's high quality university level what the fuck is the word I'm looking for? Classes you can take for free, I think. Derek.net gives me something to listen to while I work on my own project, so I appreciate it. Nice to hear. And good luck on your project. And Arthev Life, what's up? Thank you for the raid, always appreciated. Hope you had a wonderful stream. Imana Pro, can you show us the progress? Maybe not the general progress, but we're gonna get into this terraforming stuff. Yeah, but it's hard when no one tells you what mistake you did. Oh yeah, it is, but you're gonna get used to that, because most of the time you're gonna have to find your own mistakes. That's just how it is. Earth of Life, hey, was good, nice. Any new progress to report on the Twitch game? Okay, so we have simple terraforming in place, but we have a little bit of a problem, as it usually is, between patches. And it's a weird problem. So the good thing is, all the checks, out of bounds checks, etc., they work. We never get a runtime error anymore. We don't even get warnings. I don't know why we would get that. But the out of bounds checks work a little too good, because this is what we get. So if we terraform this square right here. No, it was actually, now I wonder if it was this one. I think it was. So when we terraform this one right here, we terraform, we don't touch these vertices or these height map values for this patch, but we do touch those vertices for this patch. So that just means that we are a little bit too harsh on an index check somewhere. And we're going to get into that today, but first of all, I'm going to make it easier to spot the mistake by creating a custom terrain material, which will print some height data values and stuff like that. Earthdev Life, I was working on a game loop today to be able to leave it running while I stream. I love it. Now we have some coin spawning and high scores. Nice. I remember there being a guy I followed pretty frequently on Twitch. Oof, I don't remember his name. Give me 1 sec, I might pull it up. He was working on a very respectable Twitch game. I don't know if he streams anymore though, haven't seen him live in some time. Where can I see my followers? Here. What was his name? Seratar. Wonder when he was live last time. He made a Twitch game called Ravenfall. It was very impressive. Imena Pro, well, ChatGPT tells you. Yeah, ChatGPT tells you sometimes, but sometimes ChatGPT is wrong, you know, and maybe not the best quality coder out there. Sometimes better than me or the user, but sometimes worse. My game will be single player first of all, and yes, I am streaming over on Twitch too. Okay, so initially when I saw this error here, I thought it would be pretty easy to find this error, but turns out it wasn't. There's quite a big chain here. If I actually, let me double check. Yeah, okay, so it's when we change this one. So So the problem basically stems from us going one step further here when we shouldn't do it. I know. I think I know. 1, 2. 0, 1, 2. Could this be as easy as... But then I wonder... I just want to check if this is the problem. If it's not, we're gonna implement a custom shader for the terrain to make it easier to find exactly what's wrong. But what I think is wrong is grid points together here. So I think the problem stems from us when we change it here, or when we paint the depth map, we fuck it up here. So basically for a rectangle with a width and height of 0, we loop through that 0 anyway. But making it to this, so being a little bit more harsh on the constraints, I think it's gonna work in the opposite direction. So I think the problem is deeper than this, I think, but I'm still gonna test it. Time to stick a rock over it. Yeah, that would be an easy fix. Anytime two terrain patches don't match, just stick rocks over it. I'm a little bit afraid that... Oops. Still looks pretty good. Okay, then we have this problem. So, two terrain patches again, if we put it here, now we have this problem. So, we do the correct here, we don't do the correct here. So it's always a little bit of a mismatch when it comes to this rectangle over the terrain. In Mena Pro, hey, can I ask you one thing? Depends on the question, but shoot. I can always choose not to answer right. But if we take a look at this, if we do... yeah, this is... yeah, we don't want this. So we definitely want this, but the issue is somewhere else. So let's take a step back and implement a custom shader that prints the height map, maybe pixel perfect, or we'll see. Environment controller terrain base. Right now we just use object prototype material and yeah. So let's do terrain shader, indirect terrain shade. Let's just create a terrain shader, but actually let's take world normal shader. Let's take terrain shader indirect. Can you explain everything while coding, like when you do player prefs, explain what to do, because when I will rewatch it, I can learn good. Yeah, I will try. I always try to explain in parts what I'm doing. Explaining every single thing would probably be too time demanding. Witworthy, dang, I haven't seen this before. Great work on the character. Thank you, appreciate it. It's been a ride. When I started this project, like, modeling wasn't my strong suit, and I've learned a lot. I feel way safer in Blender now. And yeah, right now we're working on terrain tools, but it's like in-game tools, so the player will be able to terraform his or her garden a lot. So we have to manage to implement like real-time terrain altering and everything that comes with that. Yeah. Okay, let's see, what do we have here? Albedo, ambient multiplier, smoothness, specular, highlight color. Oh, great, we have everything we need here. It's just as this was an indirect solution, and we want to make it direct, I suppose. Terrain data texture, beautiful. Object to world, we're gonna skip this. Delta. Yeah, okay, now I see where we are. Calculate instance UVs, joink, or whatever people used to say. Approximate normal connected neighbors. We don't need this one. I don't need this note anymore. We're gonna have a height map. Actually, I'm gonna have a terrain data texture. Sampler 2D. I think we're gonna read this texture in a different way. Do we want text 2D, low D? Yeah, we're gonna change this from sampler 2D and rely on a macro instead. What is it? Terrain data texture. Is it texture? Yeah, I think it is. And then you can do something like, I always forget, is it write it like this and we get a pure black? Oh wow, yeah, I could see that being a hassle to implement. It has been a hassle, but, big but, it has also been extremely fun and a great learning experience. That definitely has to be said. We don't need any of these. Calculate world space position from text. We don't need that either, actually. Okay, so let's see here what we need now. Vertex, fragment, light mode, universal forward. Can we rely on that one? I think we can. We do calculate blin fong here. We have a shadowcaster pass as well. I think. Oh, yes. Let's see. What was the thing here? Yeah, when we work with extremely big terrain, we had some problems with the shadows, and that is because when we generate the shadow map, we need to apply shadow bias here. Ooh, do I need to keep? I think we can simplify this quite a lot. Like, we don't need to do these things here, I don't think. UV position world space. Yeah, we're gonna simplify this quite a lot. So we can do this as well. But we still want this, definitely. Light direction. Okay. Yeah, we're gonna simplify this as well. Do we want this? Yes, we do. Okay, now we can finally start, I think. I'm just gonna open up a reference here. So, the previous shader did a lot of heavy lifting on the GPU. We pretty much just sent in the texture and recreated the positions, the normals, the tangents, pretty much everything in the shader. This time around we're not going to do that, so we're actually going to get a position OS that is good. We're going to get a float 3 normal OS. And tangent OS. We're actually going to get a UV as well. I think we can check terrain data. Oof, I love this. Like future improvements we can implement quite easily. Let's see, terrain patch mesh data. So these are the things we're going to get in our shader, and right now we represent them by float 32. So each value is float 32. We're going to cut this later on. But let's see here, position, normal, tangent, UV. Right now they are floats, so this looks good. Vertex shader output, I don't know if I want to put the tangent here as well. We can start with this and see how it goes. Does Unity Learn teach you coding, or like how to use Unity? I think it teaches you both. I started learning Unity in 2017, I think, and it looked a little bit different back then. But I remember it being a good learning hub, so to speak. No complaints. I'm just gonna put my mobile phone in focus mode so I don't get distracted. Okay. So here I want to rely on these two. Vertex input, normal input. And what do we want to send onwards? We want to do output, position, world space. Do we have it? Yes, we do. Clip space, we do. View space. Wesley, what's up? New distraction here. Yeah, but that's like a better kind of distraction, you know? Good morning. Or good evening. Witworthy, I would say it's definitely a good first engine. Yeah, I think so as well. Like... yeah, I have no complaints when it comes to my like entry period into Unity. It was extremely easy. Animena Pro, what are you streaming with? I'm streaming with OBS. I've gone through multiple different streaming softwares, and like the open source OBS is by far the best one I've tried. So that's what I'm sticking with. Morning in between 2 work shifts now. Ooh. Unity is great. It is not as shiny out of the box as Unreal Engine. Yeah, I tried Unreal Engine as well. I think it's definitely a bit more shiny, but it also... I found the learning curve to be way steeper for Unreal Engine, like way steeper. Yeah, Streamlabs is built on top of OBS, that's my understanding as well. With a lot of bells and whistles I don't want, and a few things locked behind a payment plan these days, I think. And Whitworthy, it's a good engine. The only concern is owners making questionable statements about monetization. Yeah, that's to put it mildly. I think the focus at Unity has been a little bit too spread as well. So they have been like spread thin, focusing on a lot of bells and whistles, instead of getting the like core functionality 100% there, if that makes any sense. You can't make a 2D game in Unreal. I think you can. Like, it's all depends on how you use the 3D engine. Maybe it's not built around 2D games as much as Unity is in some regards, but you can definitely make a 2D game. Emana Pro, do you have Discord? Yes, I do. It's in the link below. C++ means you have to do your own garbage collection, if I'm not wrong. I think they have a lot of great things in the C++ now, which means that you could get around not having to do your own garbage collection. But I don't know. It's been a couple of years since I worked with C++. And as to Slay the Spire 2 being in Unreal, I have no idea. Wouldn't shock me. Okay, we want to send out the normals as well. Normal world space is equal to... Actually, I wonder... Oops. Do we use tangent here? Normal, position, light direction. No, we don't. Maybe don't even need to send it. We're gonna need to have it in the future. So, unless I have missed anything here, we should have a running shader, but I usually miss a lot of stuff. So, I'm gonna let the compiler tell me. Yes. At line 4. Okay, so this is not how you do... Oh, maybe you need to do... What is it? Let's take a look at the reference here. White and then these. So if we do this... Oh yeah, 2D instead. Line 88. Yeah, we forgot to do... So now when we have named them to this, we want to do... well, here, position world space. I think we want to do this. And we're going to have a similar problem down here as well. Position world space, we want to change this to input. And we actually want to add this. We don't need this anymore. But that's not what it's complaining about. Position world space. Oh, Slay the Spire 2 was one of the games that jumped the Unity ship. One of the many. Sharik, what's up? How are you doing today? Any thoughts on Vanessa? I don't even know what that is, so I guess I don't have any thoughts about it. Art Dev Life, do you know how can I generate a texture in one shader then be used on a second pass of the shader? I'm avoiding scriptable render pipeline. I have a Voronoi noise and I want to calculate normals based on the Voronoi value and then generate a normal map out of it. Or should I do it on the CPU side first and then pass it to shader? Depends on, if you're gonna change it often, I would do it on the GPU. If you're just gonna do it once and then keep that one, I would do it on the CPU, I guess. The interwebs tells me Slater Spire was made in Godot, says Defesmo. Good morning, by the way, Defesmo. So Art Dev Life, when it comes to that question, I actually do something similar here. We have a terrain data container, and here we have when we create the terrain data container by this constructor, we actually generate the height map, and we do it with a custom class I wrote that is a Perlin noise texture generator. But you actually have Unity math. First of all, you have math that's specific to Perlin noise. But so this is basically, I'm doing the exact same thing you're asking about here, but I'm doing it with a height map. I know that I'm just going to generate it once, and from there on out, the player is going to alter it. So for the initial generation, I do it on the CPU. So we generate it to a noise texture here. And this is a texture 2D object, and then when we click apply here, it also exists on the GPU side. So then we can do, I'm not entirely sure I send this one into the GPU though, but I have a, is it ground? Here I think we do. Yeah, here we do. So basically we let a gradient texture generator and a Perlin noise texture generator generate a texture 2D, and we apply it so it's on the GPU side as well, and then we call link in texture in material. So here we just take the material, set the texture reference, and that's one way to go about this. But my outline solution does it in a different way. That's where we play around in with the custom render pipeline, because we're gonna have to generate one texture each frame. So we do it for the full screen in a custom renderer feature, and we do it all on the GPU because we want it to be quick. My problem is that I will need to calculate normal using the values of the texture. So are you going to have to recalculate the normals often or just once? Every frame. And you don't want to do it in render pipeline. Yeah, then I think we do something similar here as well. Yeah, we have a solution, terrain data container. Here we have a constructor where we send in a texture 2D and then we set the terrain data here. The way we do it here is we do a graphics split, and this is being made on the GPU. So we pretty much have a temporary render texture, and we have a texture 2D, and we want to put the data in the texture 2D in the temporary render texture. So in your case, I guess the texture 2D would be the Voronoi noise, depending on if you generate it on the CPU. And then you would do a graphic split with that Voronoi texture to a render texture. And the good thing with split is that you should be able to use a material here. So you can actually add a custom shader. So you pretty much take this data, put it in this texture using X shader. And in that shader you can do a lot of calculations. So in that shader you could calculate normals from the height map or the noise that you have. The problem with the render texture then is that the result is on the GPU, but if you want to use that normal map on the GPU later, that's good and fine. But if you also want it on the CPU, you're gonna have to do something ugly like this. So read it back from the GPU, which is costly as fuck, I've heard, to get it back on the CPU again. But you could definitely do it like this, and then your render texture here would be tied to some global shader variable. So when this has been done, you can access that render texture in other shaders and such. Something like that is what I would opt for, but yeah. Graphics blit, extremely powerful. And this is also something I rely on in my custom render feature for the outlines, I think. But there we do it in a render feature, yeah. Yes, good luck. It's very interesting, and some, like, can be a bit tricky sometimes to get like the CPU GPU communication and stuff like that working, but yeah. Okay, terrain shader. Did we still have an issue here? I think we had. Invalid subscript position world space at line 131. So here, I thought we fixed it by setting input here, input dot position world space. So I wonder if I hope it's just a recompile error. No, it's not. What am I missing? Don't we have position world space here? We do. Vertex shader output. Oh, yes. One sec. Okay, so this is the vertex shader. So here we only have position object space. Did we actually have position world space here previously? That is quite weird. Okay, so what we want to do is we want to calculate this position world space. Oh yeah, we did calculate it previously as well. So we do this, and then we can do vertex input position world space, I think. And now we have normal world space because we also need to do this. So from normal object space, we calculate normals in different spaces, and the one we're interested in is the world space one. Oh yeah. Although we don't need, so we have two passes in this shader, one for calculating the shadows and one for calculating the output color. And for calculating the shadows, we don't need as much information. Wonder if we can keep it like this. Okay, finally. So let's see here. What I actually want to do in this shader is, I don't think we want to calculate the I don't think we want to calculate the light for now, so we're going to comment that one out. And we want to have the UVs in the fragment shader, because what we're going to do is we're going to read this texture, which we can actually put down here. And I don't think I want sampler 2D. I want to read it as, to be frank, I don't really know the difference, but I think we want to use, when we read the texture later on, I think we want to use this macro function or whatever it is instead. So terrain data texture, and then in the fragment shader I just want to read the value here and output that color, whatever we read. But I only want to output the R as well, the red channel, because that's our height map. So we're gonna do this, and is equal to this, but terrain data texture and terrain data texture sampler. And then we're just going to return float for height value. Ooh, height value, height value, height value, height value 1.0. Any errors? No. Okay. And environment terrain shader. So let's create a material out of this as well. Terrain default material. And we're going to keep all of these as they are. And I also want to do hide in inspector. So this one, this texture, we're actually going to set this from script instead of manually setting it here. So where do I want to set this? If we go to terrain patch, we have a function called set material here. This is where we want to do it. Although I wonder, that should be okay. So if we do private const string terrain data what do I usually call these? Action Terraform uses them a lot. So just a const string that is the same as in the shader. Shader property name. So let's see, terrain data shader property name is equal to, for now we're just going to hard code it like this. I'm gonna have to look into another solution, but it's this name we want. So as soon as we set the material, we also want to do mesh renderer dot material set texture, and here we want a constant property name, terrain data shader property name, and the texture we want to do here is, I wonder if we have access to it, but I think it is terrain data dot terrain data. Oops. Here we have it, terrain data container. We have texture 2D data. Fuck it, let's do. So we can only set it from within here, but we can get it on the outside. So we just do terrain data. So now we should have set up the reference to the texture 2D. Hopefully what we will get now is one last thing. The material for terrain here, we want to change it to terrain default material. Okay. Yeah, let's try it. Okay, I did not anticipate this. Object not set to an instance of an object. Terrain patch 168. Okay, so terrain data has not been set here. That is unfortunate, which unfortunately means that we have to add some checks. I'm okay with that for now. So if terrain data is not equal to null, I think yeah, we can do this, but this also means that set material is called before we generate the terrain data for some reason, which means that when we generate the new terrain data here, we want to check if mesh render dot material is not equal to null. Now we want to do this as well, and this is not the only place we want to do it, so yeah, we're gonna have to do it like this. A bit not the cleanest way to do it, but hopefully it will work. Okay, so it should be visible here where we have the patches. Do we only have a 16 times 16? Here we have a patch. And here we have a patch. So these two, we should be able to see. What's up, Cypher? Long time no see, or a couple of days at least. I think it's going pretty good. We just have a tiny problem left to handle. And oh yeah, the way we render this one, it's not Yeah, I think we want to render this with a little bit of an offset, because vertices should match. It's okay, let's just see what happens if we start screwing with it. Yeah, then it becomes black down here. And if we do this, do we have a problem here? I think we do. This actually messed it up more, I would say. Like this made it harder to see, so it had the opposite effect. Because we have a little bit of an offset when it comes to actually. Good morning, Geralt. Cypher, yeah, I've been lurking. Appreciate it, appreciate. I had music blasting or meetings. Yeah, I get it, I get it. Fuck, this actually made it worse. I was hoping that this shader would... where do we want to go? Okay, so what happens if we change it here? Like here it works, I think. It's hard to see. Here we have a problem, I would say. Do we? Yeah, this shader made it worse, that's for sure. Terrain shader. So let's go with this solution. Hopefully we don't have any problems. Okay. Yeah, this problem still occurs. It's... So, it seems, to be honest, like whatever height change we apply to these pixels here are applied to these pixels here. So we have one offset when it comes to getting to different patches. And I think I might know. I fucking know. Ooh, I'm 90% sure I know why. Yes, it has to be. It has to be. So, terrain patch. When we alter the terrain, we do it by or when we alter the height map, we do it by this one. And here we have something called grid points getter, get terraform data from circle. This one creates a rectangle that is the area we are altering. The only problem, however, is this clamp here. So for this patch here, the alter, don't I have, yeah, we have it there, it's just hard to see. Can I do 0.5, 0.5, 0.5, or can't we see it here in the editor? No, we can't. So the problem is basically our marker is located on these 4 squares here, and we have a little bit of an error margin when we get the points. This right here sucks as well. What the fuck? Oh well. So we have this, we have the marker on this square here. So when we calculate the rectangle for this one, we get a start point here, and we get a width of 2, I think, and a height of 2. So 1, 2, and 1, 2. And that is our rectangle, which we do the terraforming. But so we find all the terrain patches affected that are within the cylinder made from this one, and this one is a little bit bigger than the area we actually terraform. So we actually get this terrain patch as well, but when we try to recreate this rectangle for this terrain patch, we actually see that the start position is outside of the terrain patch, but we clamp the start position to be between 0 and grid size -1, because we don't want to go out of bounds when we get values from the array. But by clamping that start position, we clamp it to start here and go 2 up and 0 to the right, which means that we alter this pixel, and this pixel, but the full rectangle is actually outside of this terrain patch, so we shouldn't alter any vertices whatsoever, and that is the problem we're having. And I think it works the other way around. So when we have, so this is the case for indices below 0. I think we have the same problem for indices above resolution, or resolution -1. So what we could do is we could implement a check here and return, I don't know, a null terraform data, but then we would have to check that null. So when we get this terraform data here, we send it into alter terrain data. So we could either do that, we do those checks in that method. If this one returns false, or null, if this one is null, we don't call this one. That's the most straightforward way to do it. Or we could implement grid points getter, get terraform data from circle. Here we could do, or we could do a check, does circle exist within terrain patch? And I wonder, so just a function that returns a bool. If that one returns false, we skip doing both of these. If it returns true, we do both of these. What would save us the most time? I think we can simplify the calculations quite a lot here. Or maybe not. Maybe we will just end up doing duplicated calculations. So we actually truncate the circle origin and we truncate the radius index length. We're gonna have to do those as well in the check. Basically what we want to do is we want to do this and then we want to check if x start and y start, like if these values are outside, or like if both of these values are outside the patch indices, then we know that, or actually if this value and this value is outside the patch indices, then we know that we're entirely outside of the patch in the x direction at least. And if we are in one direction, we should skip. So, but we still need to check for both. And so that means that if we would implement a is circle within terrain patch, or is truncated circle within terrain patch, we would have to do this one extra time, this one extra time, and this one extra time. Not the clamp though. So either do it 2 times or get the values and send them onwards, but I think I'm just gonna opt for a terraform data null, to be honest. The question is, it's a struct, so it's a non-nullable data type. We could also we could reorder stuff so we do these calculations outside, so we don't send in circle radius or circle origin, we send in these, which means that we don't need, we still need this one. Decisions. Like the reason I want to do the checks on the truncated values here is I see this scenario in front of us that we might have a little bit of a difference between the float values and index values, that sometimes we have an error there, and the error might lead to us not including all the indices we want to include. What we could do we could extend terraform data, so we have position and we have position clamped, and we have dimension, and we have dimension clamped. And then we could add a nice function within this one. Maybe that's the best solution. It adds a little bit more data being thrown around, but it should be okay. And I think that should be pretty clean as well. So what we could do is we could just do x start y start, and then we need to handle this within. Yeah, I think we're gonna do it like this. Vector 2, what is it? I think there should be a better term for this. So we have a rectangle, we have bottom left corner and top right corner. Rect unity. They use, yeah, they have center, so position. Term for bottom left and top right corner of rectangle. Okay, so Microsoft goes with bottom left. Public vector 2 int bottom left. Public vector 2 int top right. I wonder if I just want to send in position marker space. Bottom left, vector 2 int top right, position marker space, circle range, inverse lerp. Oh yeah. We use ranges here, but we do circle origin as index. Actually, what the hell? I wonder if I want to do terraform data. What do we want here? We want circle origin, index, radius index, and then we do this, but we do need grid size here. Terraform data bottom. I think we're gonna send in, I think we're gonna leave a lot of calculations to this struct actually. A lot of changes now, but I think I just want to send in circle origin as index, vector2 int. So vector2 int center, vector2, or actually just int radius and int, or actually I think we're gonna range bounds. Yeah. And then we're going to do a lot of these calculations in here. So we want bottom left, top right, position marker space, marker step size. Good morning, PG King. How are you doing today? Okay, so bottom left then is, let's do bottom left is equal to new vector2 int, and here we do center.x minus radius, center.y plus radius. No, minus radius. Yes. So this is bottom left. Can we fit this on one line? Yeah, straightforward. And then we have top right, new vector 2 int, center.x plus radius. Yes. So now we have bottom left and top right, non-clamped. So I think I want public vector 2 int bottom left clamped. Public vector. Like all of this creation of different data structures and stuff like that doesn't sit that well with me. Like we might want to optimize it a bit, but struct, it should be okay. But now we want to clamp it, so it's basically going to be, so let's do bottom left clamped is equal to new vector 2 int mathf.clamp bottom left dot x 0 bounds dot min, and this one we need to have on 2 lines, I think. Can't convert to int. Do we have to do a cast if we do it like this? Should be okay. Like, we'll see. What's up, Castle? What is he using for that code suggestion? To be honest, I don't know. I think it's the Unity package. One sec. I don't actually know. I guess I got it correctly set up with Unity. It wasn't listed in extension at least. Bottom left clamped. Am I doing this correct? Bottom left 0 bounds. No, I'm not. Oh, actually, I think we can do it like bounds.clamp bottom left dot x and then cast it. Unfortunately, my custom function or custom class range doesn't handle any other data types than float for now. It's a little bit unfortunate. I have it as a task to make it generic. So pretty much we clamp bottom left to bounds, which we send in here. That's bottom left clamped, and then we want to do top right clamped. Okay, so that's all of these. Position dimension. I don't know if we need to use these. We're gonna wait with those, but we need to calculate these. And these are done in a little bit of a weird way because we want to do a range here. Although I wonder, circle origin as index y. I did it this way because I wanted to rely on inverse lerp here. So I think we can just do y circle range. New range, and let's take a look at these. Circle origin as index minus radius as index length. That is pretty much this. So we have whoa. I think we can do it just like this. No need to do it this way. I don't know what I was thinking, but vector 2, so position in marker space is equal to new vector 2. Come on. And here we should be able to just do mathf inverse lerp, and what do we have? A, B, and value. Bottom left. Ooh, we want the clamped ones here, I think. Or do we? No, we don't. No, we don't. Bottom left dot x, top right dot x, and the value we have are x start. So bottom left clamped dot x. So I know this might look like a bit of a mess, but basically what I'm doing here is that I'm calculating UV coordinates, position marker space. I'm calculating UV coordinates. So UV start, UV step size. So it's basically this rectangle we use. I want to represent that rectangle in the brush texture space. Yeah. So this is the full square in the X direction, min value and max value. And those represent the, so this in the UV space, this is 0 and this is 1. And I want to calculate where the clamped value is there. So is it at 0 or 0.5 or, and so on. And we also want a we want to do this for the Y as well. And then finally we have this UV step size. So I pretty much just want to calculate like how much does one grid step, how much is that represented in UV space. And I want to make it the same way as we did it here. So UV step size is equal to radius. So 1 is the full size and we get the diameter. Actually, does this make any sense? Oh, yeah. So the full size of the brush texture is in object space 0 to the diameter, or yeah. And that's pretty much just what we do here. So this is an integer. So let's say that the radius is 2. That means that diameter is 4. So we have 4 grid elements, which means that the full brush will be represented by 4 steps. Something like that. Might have some small error here. I guess we will find out. Okay, so now this terraform data is structured quite differently than it was, but we should be able to do return new terraform data. So now we create this one from center, circle origin as index, radius as index length, and the bounds here are the grid bounds. So new bounds, actually, is it a range? Yeah, it is. New range 0 grid size -1. So all of this, the mess we did out here, we now do it in the constructor of this struct. A little bit cleaner, to be honest. So we did all of this because we wanted to add a check on the result. I'm not going to implement the check just yet. I'm just going to implement, we still need to change this one based on the new use. We have a little bit of a problem here. But when we have that in place, I'm just going to run it, see what kind of result we get. I'm hoping for the exact same result we had previously, including the error we have. Or not error, but like bug. So yeah, I want one of these in terraform data, but we're gonna rename it to public vector to int size, I think. And size is actually based on now when I think about it, let's see here. If I were to do public vector to int size clamped, if I were to do this, then we could actually calculate the UV outside. Then we have all the information we need for UV, I think. But then we would have to do inverse lerp. Like if we were to rely on only these on the outside, we would have to do inverse lerp in every iteration of the for loop. I'd rather do it just once here and rely on UV step size. So we're going to keep it like this, but size clamped here is the only thing we need, I think. Size clamped is equal to top right clamped dot x minus bottom left. Oops. Okay, so now here we should be able to do size in size clamped, and position is our new bottom left. And the idea later on is to do so terrain patch alter terrain data. We get terraform data, and here we do something like if, let's comment it out for now, if terraform data dot is within patch or something like that, or is within grid, like grid points together. I want a terraform. We're gonna go is within grid, I think. I still want, or do I? Oh, we can just do is within bounds. That is generic enough. We have the bounds. Oh, do we want to keep this one? We're amassing quite a garbage pile here, to say the least. This one is going to be in the garbage either way, so we might as well just hold it for a tiny bit longer. I think. And I think we can use all of this data for some fun stuff later on. So it's not only going to be used for what it's currently being used for. So yeah, the idea is to do something like this later on. So we create, I don't know what the correct term for it is, but property or whatever for this, and only do it if it's within bounds. Like if it would be possible to do is within bounds way before we do all of this shit, it would be preferable. So we're gonna add a little bit of a note here later on, like possible optimization. But for now, we're in the rough, so let's keep it. Let's see what we get. I hope that this scales well. Actually, for now, let's go with prototype material. Like, and when I say I hope this scales well, like right now when we're testing, we're working with extremely low resolution terrain. I hope this solution scales well when we up the resolution of the terrain, but we will gonna have to find out. So this should work similar to how it did, and I think it does, which means, let's see, that we should still have we still have a problem, but we have a different problem. Yeah, the normals gets fucked up here. Not what I... Ooh, actually, do we have... Yeah. How did I screw this up? Bounds. Grid size -1. Ooh. And I screwed myself yesterday by not committing this change here. But, oh, here is how we use the old rect. 0 and grid size -1. Oh, I know what the problem is. Of course I do. I hope I do. No, I don't. If this was the problem, it was just lucky that we didn't get a runtime error. That's for sure. Okay. Yes, there we go. Now I think it works like it did, so we still have this issue. I need to do something about the camera view when we are in terraform mode as well, but we're gonna get there. Okay, so doing it, yeah, and that's the same error we have. So if we do terraform right between two patches, it works. So the problem is, yeah, now we're back at where we were. The problem is when we do it right at the edge of one. Wasn't that the edge? I thought. Yeah, we need to do it a bit more on the edge. So there we go. That's the problem we're trying to fix right now. So the problem here is that, yeah, we clamp it the wrong way. So this one is entirely outside of the terraforming rectangle. But since we clamp it, it still thinks that the indices at 0 should be, or the indices at 0 or grid size -1 should be altered. We want to leave it unaltered, and that's what we're gonna have to check for. I sure hope this is a problem. Although I'm happier with how this terraform data is structured with this. So even though this won't fix it, it's still not for nothing. So is within bounds. Terraform data. Do I have something like that in range? Clamp. Yeah, I guess we could do. So if value return value is less than min or value is bigger than max, right? So if this one is true, this one is false, but this one is this should be it, right? What's up, JD? How are you doing today? Do game companies pay their employees with investor money? I guess in some cases. But then again, I'm probably not the best person to answer that. But yeah, I mean, like sometimes when you do the investor rounds, you ask for investment, and part of that investment is going to have to be used to funnel into the payroll. So I guess the answer is yes. Or maybe in some cases, as Cypher says, it all goes on blackjack and hookers. That might very well be true in some cases as well. Unfortunately, it might be. Yeah, so if both of these are false, if one of them is true, we return false here. I think this should be it. Logic mathematics is not my strong suit. So we should be able to do bounds.is value within range this is going to be a lot. So we need to check bounds is value within range. We need to check. We pretty much want to check bottom left dot x and okay, we're gonna have to check all of these. I think so, unfortunately. So basically what we check here is, but this is not true. Yeah, what we want to check here is if this one and this one is within bounds. Like if this one is outside the bounds and this one is outside the bounds, that means that yeah. Or this one and this one is within bounds. So this is before clamped. So we just want to make sure that, like, is one of the points within bounds in the x direction, or is one of the points within bounds in the y direction. If this fails, all of this fails. Let's try it. it's a little bit unclear, I would say here. So it's within bounds. What bounds? But then we check. Oh, it has its own bounds. Okay, so what is its own bounds? Okay, it gets sent in here. A little bit unclear, I would say. What we could do is wonder. Resolution, delta, offset, or in here we it would look way cleaner in code, I think, if we would do patch bounds. Instantiate position, dimension, resolution. Patch bounds. Do it like this, and then we can change terraform data. And here we don't send in grid size, instead we send in, first of all we send it in the last, and we do get terraform data from circle range bounds. So that would mean that we do, one sec, yeah. So we send in patch bounds here when we do grid points together, and then we do terraform data is within bounds, patch bounds. It becomes, I would say it's way clearer this way. The terraform data, is it within the patch bounds? And this also means that when we create terraform data, we don't create an additional range object that we're gonna have to get rid of later on. Instead, we create it on terrain patch creation, and we have it here. Reuse it. So we introduce reusing and a little bit less garbage. So that's a win-win. Or I think it's clearer, but that's subjective. Okay, but I don't think anything else would change. The question is how we use bounds here. Yeah, we use it the correct way. Also wonder, should be okay. Fuck me. Okay, so that didn't fix that issue. Big question mark. Okay, I don't see why the logic wouldn't hold, so I wonder if I just screwed it up somewhere when we actually implemented it. Because we can see here that the rectangle we change here are, in the X direction, it's just 1 in size. We don't change these. So what the fuck? Oh, one sec. Or is within bounds. If this one and this one. Yeah, do I want a and here? I probably do, right? But once is value within range. If this value is within range or this value is within range, so I think we want to flip it like this. Okay, so the bottom left is within the patch. That means that this hole is true. So then we just need to check this one. Is if one of these are within bounds, we want to continue. Yeah, we're fine with just one of these being in bounds. Size clamped will take care of it. So what I think I'm seeing here is, so for this one, for instance, yeah, the start is outside and the end is outside. So the start is here, the end is here. Both are outside in the X direction. Oh, it has to be. Ooh. Yo, what's up there, Abo? How you doing? How's the smart home going? Look at this. So here we actually terraformed right at the edge of a patch, and ooh. I hope these are just shadow artifacts, because I think the normals work as they should. Yes. Ooh. So in that case it worked. Ooh, yes, I think this is what we want to get. This is what we want to get. I think we got it. I think we do. The syncing between we have some shadow artifacts. Having so much fun, was about to sit and solder a bit. I thought I'd just lurk a bit over here. Appreciate it. And good luck with the soldering. And yes, editable terrain at runtime. That's gonna be a pretty big part of the gameplay. And I think we have it. We have it working with the debug brush. And the debug brush is not the best one. And what we're seeing here is hopefully also just shadow artifacts. Yo, what's up, DevSpiers? Thank you so much for the raid. Hope you had a wonderful stream. Let's see. Yeah, it seems to be shadow artifacts. And I'm okay with that. And I mean, we already have... it's low resolution terrain, but the performance is nothing to complain about. I love it. I like it. Still, we get a performance. We still pretty much want... I think we want to offload this on a separate thread, but I mean, at least it's working. Can you build up as well? The idea is to be able to build up as well. Right now the debug brush just removes. Or it actually sets the height map values to 0. Wow, pretty good song as well. I'm gonna save this one for future use, I think. Let's see. And I don't know if you catched it, DevSpies, if you're still around, but thank you once again for the raid. It's appreciated. Let's see what the song name of this one was. Feels like it would be perfect for a devlog, I think. Oh, thank you, Spires. Appreciate it. It has been a ride so far. Incremental, small progress each day. So, the next question is, does this solution, or does this implementation of terraforming scale? If I were to up the resolution of my terrain, will we get new issues or not? I'm pretty sure we will get way more of a performance loss though, but that's okay. So let's go with 512. So the only difference here now, our full terrain is going to be 128 times 128 units or meters. But instead of the full terrain being 128 times 128 vertices, it's going to be 512 times 512 vertices. What does that leave us? So 64 times 64 patches, that's not... let's try it. I was pretty happy to see that the initial generation of the terrain doesn't break, at least. Okay, so now we have a grid like this, and right now the brush just sets the height maps to 0, and then we actually also generate the affected patches again. We're gonna optimize that as well, I hope. But I'm a little bit worried about like the communication between patches, and this result here shows us that terraforming right at the edge of a patch works, or one step inwards as well. Yeah, and performance. Actually, I have the... I think we should have it printed here, so we can hopefully see what takes the longest time as well. Terrain patch fetch complete, so that's just getting the patches affected. That's quick as hell. So that's an overlap cylinder physics call. Then we have terrain patch height data update complete. So here we update all the affected textures. We're doing it in a very unoptimized way right now, but this performance is still impressive as hell. Terrain patch mesh data update complete. So this one is the most heavy one. Don't I reset the clock between terrain patch? I'll stop terraforming. Okay. Yeah, this one doesn't scare me as much as... Okay, so this is positive. Like, we're still doing... A lot of the parts are way unoptimized. I guess we could probably get this down to 1/3 maybe. We'll see. Darabo, I wonder how high you can go until it breaks. So, the environment, the height maps are always between 0 and 1, right? The height maps. Because they are represented by color in a texture. I have chosen to represent them by color. And we're gonna look into that as well. We might go with a different way of doing it. Oh, in resolution. Oh, yeah, we can try higher. Definitely. I think though, like when I was envisioning the terrain, I think this is pretty much how small I would go, I think. So for terrain, I don't think I want higher resolution than this in the game. Ooh, what do we have here? Ah, it looks good. Yeah, and don't break your stream. Yeah, that could definitely happen. And I just have to say this as well. So the current implementation of the marker shader looks like when you have a let's see here, a slope that is very slopey. The fuck is the word I'm looking for? Oh well, when you have a big height difference between two neighboring points, you get this visual artifact, I would call it. Thankfully, or I don't know. I haven't really decided how I want to handle slopes in this game. I don't know if I want to allow it or not. By the way, I missed you, Derek.net. Checking in, managed to fix the bug. Yes, we did. Yes, we did. So, before we continue here, what I'm looking forward to the most is to add a different type of brush. I want a gradient brush. So, we alter the vertices more towards the middle and less towards the edges. But before we dive into that, I want to let's up the resolution a tiny bit as well, but then I also want to try, so let me show you this terrain patch. So we have this method, alter terrain height texture within circle. So we calculate which pixels for each patch we want to alter in the height map, and if it's within the bounds we alter it. And then we have update vertex data within circle. This is actually the method where so first we update the height maps for all the patches, then we want to adjust the vertices and normals and such so that they represent the height map. This is the solution we're opting for, but right now when we debug the height map altering, what we do here is we just loop from 0 to minus or to resolution, and we recalculate all the vertices. So this means that when we did the terraforming here for this patch, we actually only altered a tiny part of one column in the height map, but we recalculated the position and normals for all the vertices. So that means, I don't know what this is, to almost 20 vertices. So instead of just recalculating 20 vertices, we recalculated 64 times 64 vertices. And still powerful stuff, I would say. So would love to get this in place as well, and we're gonna do that. Derek.net, thank you so much for donation. Appreciate it, appreciate it. And for the kind words. Like, I appreciate it very much, but I'm a little bit sad that I don't have the YouTube donations up on stream yet. I'm sorry about that, but thank you so much. Okay, let's up the resolution first. And hopefully I won't break it. I wonder if I go twice. The marker, the visual marker is gonna look like shit, I think. But yeah. And entering play mode takes a lot longer. Actually, did we? Yeah, this grid doesn't say very much. Let's see here. So let's go and do let's do this and let's do this. Yeah, way worse performance though. So we're up in, what is it? 0.15 seconds. Yeah, that's rough. That is rough. But still. And that is, once again, if we change a few vertices, we recalculate all the vertices. So now we're up to 128 times 128 vertices. But still. And the character's hat wobbling a tiny bit more when we terraform, that's a feature. What's up, Calvino? Yeah, either the hat is sentient and knows that the earth is being manipulated, or just the pure force of the manipulation. Okay, fuck. What's up? What's up? What's up? What's up? Okay, so that is one issue. Although okay, that's not great. And I can imagine that issue being hard to find as well. What's up, Ash? Nice stream, thank you. If it's pure force, the character's leg strength is really something. Yeah, that's true. we're gonna have to implement some ragdolling if that's gonna hold up. Why? So the issue seems to stem from a very large I did not want to see this. Let's see. Okay, I hope action terraform. I hope Ash, I subbed. Thank you. Appreciate it. Appreciate it. I hope the issue has to do with... So this could probably save me. We have a... Or could it? Maybe. We'll see. We have a... I'm looking for... error margin, there we go. Terraform point radius error margin. So this one is pretty much okay. So when we mark the terrain, we want to make the, when we do the physics capsule overlap, we want the capsule to be a tiny bit bigger because we want to make sure that we get all the patches affected. What we're seeing here is that we're seeing one patch being affected but not the other one. And this error margin, I set it to terrain delta. But then, yeah. Let's see. Terraform point radius, error margin. So, could this be because of a floating point error? I sure as hell hope so. So a scenario where the edge fuck. It could be. So if our radius go, no, it shouldn't be. If we had, if the radius ends, or actually, if the radius ends here and we add a margin, we don't get the other. Yeah, so if the sphere ends right here, we add the margin with this, which is just the grid delta, we might see a tiny float diff, which makes this one not being included in the terraforming. But what speaks against it is, in this case I would have had to make it twice, and I don't see that. Oof, this is a rough issue to fix. or like the cause of it is going to suck to find it. No, it's definitely not the error margin, I don't think. It seems to be always at the edges. Ooh, one sec. No, it shouldn't be this. There we got it again. And that one was also at a corner. Here again at a corner. Actually, let me do this. Environment, we're gonna go with terrain default material. And I wonder if I want to add, I just want to make it a little bit easier to debug. This issue is probably going to haunt me for a while. I wonder where it comes from. But I'm just gonna alter this a tiny bit so that we will have a marker at the edges of each patch, so I can more clearly see them. And how do we want to do this? We want to use the position object space, I think, and we want to send in something here then. We want to send in inspector, and we want to terrain bounds in object space. And we want to use it in the fragment shader here. And I want the object space to be, I want the object space sent from the vertex shader to the fragment shader. So we're gonna add a, let's put it here. So then we need to do I don't even know if this one is returned from this one. We could just go with this one. Yeah. And then in the fragment shader, we want to do calculate blend fong. And albedo RGB, we're gonna do float for color is equal to do so the idea is that object space, like the position in object space, will always be between this one. So terrain bounds might be, let's say 16. That means that our object space position will always be between -16 and 16. So we want to calculate an distance to, what did I call this one? Terrain bounds. Distance to bounds is equal to, let's do bounds, terrain bounds OS minus input dot position. Position is a vector in object space. I wonder if we could do distance. I don't care about the Y position, so we're just gonna run with float 3 bounds .0 bounds, and we want to compare the distance to float 3 input dot position os dot x, but we want to abs around this. Yeah, pretty much the same, but said here. Does this make sense? So bounds, we're gonna set this to positive. It's gonna be the same in the negative and positive direction. And we do abs, Does this make? I think so. Draw terrain bounds OS threshold. So color is going to be if distance to bounds is less than something threshold. So if the distance is less than this, then we want to return 1 0 0 1. Otherwise, albedo RGB. Okay, so it's RGB we run with. Let's go float 3 here then, and do it like this. Alf14, what's up? Hope you're having a wonderful Wednesday. Does this make any sense? Object space position. The only questionable thing I think is this, but it should be okay. And then we use color when we calculate the blindfång lighting. Let's try it. So 2 things we need to set up. We need to set up this one. We're gonna do it in the editor, so this one is the easy one. Then we have to set up this one, and that we're gonna have to do that by script. And we're gonna have to do it in 3 different places, I think. No, just one place, I think. Basie, thank you so much for the follow, appreciate it. Yes, so terrain patch. We have this information in terrain patch when we set the material, I think, because when we instantiate this, we set the dimension. Although yeah, so basically what we want to do is 0.5 minus or 0.5 times dimension. That is the dimension in the positive direction, and the negative in front of it is the direction or the maximum value in the negative direction. So, and I'm gonna make this, even though this is part of the debug thing, I'm going to add it like this, I think. So terrain data, terrain bounds, shader property name, terrain bounds OS, and we work under the assumption that when we set material here, we already know the dimensions of this one. So, oops, that's not what I wanted to do. Property name, terrain bounds, shader property name, and we just want to send in one float here, and that one was 0.5 times dimension. And yeah, we wanted to set float here. Okay, so at this point we have this one set, hopefully, to the correct value. Draw terrain bounds, this one is more experimental. So I hope this works. Come on. How bad did I write this one? Unspected token 112. Yeah, we're missing a parenthesis here. We're missing it here, I think. Still missing something here. Yeah, we do. Yeah, of course. I want a question mark there. Oh, 14, it's interesting to see how you make the game. I appreciate it. Yeah, it's quite interesting how games in general look behind the scenes. And right now, yes, I write the code, I make the models, and I make the animations as well. Pretty much everything, I think. Calvino, let me know when you need UI help. Will do, will do. Okay, this should... Oh, come on. 113. What do we have? Incorrect number of arguments to numeric type constructor. Yes, because I didn't change this to float 3. Okay, shader done. Hope this works. Environment, terrain, default material. Let's bring down the color here. We want to go with 0.5, I think. Make it a little bit easier to look at. And draw terrain bounds threshold. Let's do 0.1. Oh, probably it's difficult to do everything alone. Yeah, the workload is quite big. And depending on scopes, it's possible or not possible. But I'm optimistic. Did I... Okay, so right now we don't have any markers between these. That's pretty weird, I would say. Terrain default material 0.1. Maybe we need to go 5. Nope. Okay, so it's not working. 10. Thank you, Al14. Thank you. Okay. Terrain patch, I just need to double check one thing. When we call set material and when we call instantiate, I think it should be in the correct order, but you never know. Terrain patch, create new, set layer, set material, create new, calls instantiate, and we do it with dimension here, which means terrain bounds OS. We should have the correct data, but I'm gonna test it by doing. We're gonna remove this one for now. Hopefully it won't screw up too much. Good. So now if we take a look at this patch, we should have this one. Terrain bounds in object space. $128 divided by 8, 16. It should be 16 here. But we're still not getting it. Okay. Good morning, Fabik. I'm doing good. Thank you for asking. How about you? We fixed a bug that had been bothering us for quite a while, and I thought it was 100% taken care of, but upping the resolution reintroduced the bug, but in a little bit of a different fashion. So that's what we're sitting with right now. Sometimes it can be like that. Okay, so right now, draw terrain bounds threshold. Output position OS is equal to input position OS, and here we take whoa. Yeah, it should be okay. I wonder if yes. I'm not proud of this, but let's fix it. So yeah, this means this means that we get a point in one corner of the terrain patch, and then we compare to the position. So actually, shouldn't we have a red dot by the corner? I would have guessed, but maybe not. Okay, but that's one mistake I did. Let's remove this selection. That's one issue. Is near bounds is equal to something but terrain bounds OS minus abs input dot position object space dot x. If this one is less than draw terrain bounds threshold, or said is near bounds. I don't know if this is correct, but it might be more correct. May I ask what the problem when increasing the resolution? Yeah, hopefully I'm gonna show it real soon. When we do, as it usually is, it's a problem with terrain patch communication. So when we alter the terrain near the corner of terrain, we get an issue. Which is, yeah. Let's see what we get from doing this instead. Although I wonder... One 11... Terrain default material. Is this not what I think it is? I'm pretty sure. Oh, I guess we could do with UVs as well, to be honest. Yeah, I could definitely work with UVs instead. Should have thought about that one. Still a big question mark why this doesn't work. Let's do the UV solution. Is near bounds, because the UVs goes from 0 to 1. So but then it would look something like this. 0.5 minus abs UV dot input dot UV dot x minus 0.5. So this brings it down to be minus 0.5 to 0.5. That's... Yeah, that's what we want. And if this is less than draw terrain threshold bounds, or welcome back, Imena Pro. What did I miss? We got the terraforming to work, then it failed again. Okay, I need to think. So UV goes between 0 and 1. We makes it go between minus 0.5 and 0.5. And then we do the absolute value. So it's 0.5 towards the edges. And then we have 0.5 minus this one. If this one is less than this one, then we draw the bounds. Or we set the... Oh my god. I'm sorry about this. And we're only 3 hours in and I'm still doing mistakes like this. Of course we're not gonna see anything if we don't use the actual color value here. So that is probably... Yeah, and UVs only go to Y. Undeclared identifier color at 115. Yes. Yes. So by default it works when we have the initial values 0.01, 0.01. Okay, 0.01 might be the correct one. 0.01. And if we rely on UVs as well, we don't need to send in terrain bounds in object space. So let's do this. Okay, now let's see if we can reproduce the error. And now we have some lines to go to follow. So that's going to make it a little bit easier. 0.01 still gave quite thick lines, so I wonder if we want to go with 0.005. MNA Pro, yeah, I don't get anything again, but I just like watching game developers make a game in live and chatting with them. It's very much appreciated. And supporting them, yes. It's appreciated. And hopefully, like, now and then, you pick up some changes. Or, like, you pick up some knowledge bits. I just want to fix the look of this one as well, I think. Okay, so if I were to alter this, it works the correct way. Yeah, we don't get a red line here because we actually, the red line color, we send it into the Blin Phong calculation instead of just outputting it. And this part here is entirely in shadow. So I think the ambient color overrides it in this case. That's my guess. So I think the error we had was when we terraform something like this. Maybe not. When we terraform something like this. Fuck. There we go. Ooh. I think I'm starting to think. Let's see. Yeah, I'm starting to think that it might be a rounding error. I would be so happy if it was. Favik, isn't it annoying when you try to break the game and it doesn't break? Yeah, and the more you try without it breaking, the more hope you get that it actually isn't broken, and then you finally break it, so it's double disappointment. Does it only happen when the distance at the corner are the same length? Not sure I understand, but yeah. I'm pretty sure, like, initially when we saw this, I was talking about the margin of error we use, and I wonder if the margin of error is too small, resulting in, like, the margin of error, if we should include a patch or not is decided by a margin of error that is so small that it might be affected by rounding errors or precision. But it is weird that it does not happen on the entire length. That is also true. So the other corners are unaffected. Let's see here. I wish I had implemented a different camera angle when terraforming, but we're not quite there. Like if we do it here, yeah. Sphere. Yeah, it is. It's a margin error problem, I'm pretty sure. So, first of all, we do a nice catch, by the way, Hadoukanan. Very nice. So first of all, we do a cylinder, overlap cylinder here, and we do the cylinder a little bit bigger than the sphere. So, and the margin of error is delta. So just one delta here, which means that this one isn't included in the altered patches. And then when we make the rectangle, we get this very big rectangle. And we set all of these to 0. This one is not included, so we don't alter it at all. It has to be. What's up, Skulltag? How are you doing today? What direction is it? If it's a floor or ceiling? Yeah, I think I was a little bit afraid of. We do a math f round, so I think it's implemented in such a way that if the nearest, if we're right in the between two, the nearest one is even, or it rounds to the even number. But like I just think this is a problem of our margin of error not being big enough, to be honest. Yeah, I've been making terrain crap a lot, so seeing this in my own stuff. Yeah, that's one of the issues with reinventing the wheel, right? You also reinvent the same problems. But I'm pretty damn sure this is a margin of error problem. Like when we do the cylinder cast, we don't include this one. And it wasn't. And yeah, we base the margin of error on the delta of the grid. So the margin of error is 1 delta in length, which means that when we have a smaller grid, the margin of error is absolutely smaller, which we could probably reproduce this with a bigger grid delta, but it would happen less often. So right now our grid delta is, what is it? Let's see here. Our grid delta is 128 divided by 1028, 0.125, which means that when we do the sphere cast or cylinder cast, what did I say? 0.125. Sphere radius, I think we do plus 0.125. Oh no. Let's do sphere. And it's the diameter, so 0.125 times 2. Did it become bigger? Let's do 6, 3, 8. So yeah, the cylinder cast is actually just... And which brings me to another thing. Let's see here. There. So this is how big of a cylinder we do the cast on, and it's quite visible that is not enough. Okay, I'm pretty happy with this being the problem, to be honest. It could have been something much worse. And just to make sure, like, honestly, yeah, when we apply the brush to the terrain height map, we do it in a square fashion. So when we get the terrain patches that are included, we might as well do it in a square fashion as well. So instead of doing first we did a sphere, but then we had a height problem, so then we did a cylinder cast, we might have just opted to do a box first. If we would have a box here with a length or a size of the diameter, we would have catched this one. And with the current brush, yeah, poor selection of tools and poor selections of error margins. But we're gonna fix this, but it's time for me to just get something to eat real quick. AAB updating make it a lot easier. Okay, I'm just gonna take a 5-minute break, get something real quick to eat, and read up on what AAB updating is, and I will be back. Be right back. Okay, back. Sorry about that. Let's see. Emena Pro, thank you for dropping by on Twitch. Appreciate it. And Fabic, please remind me, are you using a square to get those edited nodes? No, right now we're using a cylinder, which was a bad choice. And enjoy that breakfast, Fabic. Tomato salad, thank you for the follow. I see him in a pro. Didn't you have an account previously, or? It has to be this. It has to be. I don't see. So let's do it. Box should be better than cylinder anyway. So it's about action terraform. And here we do physics overlap capsule. What we want to do instead is oh yeah. Sorry, I read it as I misread it, Fabic. Let's see. Overlap box. But as well, AAB updating. AAB updating. I don't know what that is. Is it related to terrain? Is it terrain specific, or what is AAB updating? Hadoken, if you're still around. Overlap box. Center and half extents. So half extents. That's half the length, right? So we want to do overlap box. We should be able to do overlap box terraform point and new vector 3 radius, isn't it called radius? Marker terraform point radius plus terraform point radius error margin. Terraform point height times 2 and this, oh, not new vector. I don't know what I'm doing. Let's see here. Let's write it like this. Oh yeah. And then we just want to remove these and this. Okay, yeah, okay. AAB is a type of bounding box, or more specifically, axis aligned boundary. MN Pro, I'm probably gonna go for another hour and a half today, I think. AAB is designed for entities. Actually, let me write this up. I want to check it out later on. Notes. AAB or access aligned. It's duly noted, and hopefully I will learn something later today. So, we do overlap box instead. With the center being terraform point, I think that's the center, yes. And half extent is terraform point radius plus error margin in the X and Z direction. And here we just take 2 times the terraform point height. So that's basically... Actually, we just need to do it like this. So terraform point height, that's the maximum difference you can get in height for the terrain. And now comes the painful moment of trying to reproduce this issue, but hopefully we won't be able to do. If I could just, maybe it's soon time to change, like alter the camera view based on if you're in terraform mode. It would have been easier to debug with that in place, but yeah. I think that's pretty much close to what we had. Jesus. Right at the edge. I think this is still what we want. Yeah, it is. Beautiful. Free flying camera is one of the first things I implement in any project I make. It is so useful. Yes. I should take after that. Jesus, that would be useful. Okay, love it. And yes, once again, okay, we got it working. Beautiful. Once again, the current implementation, when we just alter a tiny bit of the terrain, so maybe just this, we still update the position and normals of all vertices. And that was just to make it a bit easier for me to implement the debugging of the height map updates. So I wonder if it's time for this. Thank you, Fabic. Yeah, this is starting to look real good. So right now we take it all, or we update all the vertices. Thanks to this one, we should be able to just update the affected ones. A few things have changed since this one was last active though, so we might get some issues here. I want to go through it before we start executing it. Because the idea here is that instead of setting vertex buffer from 0 to mesh data length, we set it per row and just for the indices affected. But we're also doing this in a pretty weird way here, I think. So let's take a look. Origin in plain object space. And then we have offset. So this is the point of the circle we're altering things with. We transform it to object space and then we offset it, so we only work with positive values, i.e. easier to transform to indices. Then we call get grid point indices ranges within circle here, which results in grid point indices range. And this one was very fun to develop, so now let's see if it's useful or not. Although grid offset, we currently send in resolution, we just have to double check. So previously our terrain patches went from 0 to resolution, so they had a size of resolution +1. Right now we only go from 0 to resolution -1, so they have a size of resolution. I don't know if grid size oh yeah, we also worked with two-dimensional grid size previously. Now it's just a singular one, so we might as well skip this. We use it down here, we create a new range. Actually, we can skip so much of the calculations here if we just do... Oh, let me get to that soon. But anyway, we order them by Y, and then we only take the ones where circle origin as index y plus py is bigger than 0, is less than grid size. So here we basically just take, we only take the rows which are inside of the patch, and then we create grid point indices range. I wonder why we use what we do bounds for here. We use bounds to clamp. Yeah. Very simple, similar to our rectangle previously. And this is wrong. So here we transform a two-dimensional index to a one-dimensional index. The good thing is as well, let's see here, grid size, we use it less than here. Okay, we can clean this up a little bit. I'm just going to run back to terrain patch. So in terrain patch now we actually have a patch bounds, which is represented by a range. So we might as well use this one here. Get grid point indices range within circle. We're going to remove resolution here, and we're going to send in patch bounds. And then we're going to jump to this one, and we're going to remove the first one and add range bounds here. So here we check circle origin as index, y is bigger or equal to 0 or less than equal to grid size. So we might as well do bounds dot is value within range p dot y. So given this bounds, is this y index within it? Pretty much. And we don't need to create a new range here. We just send in bounds. Although I have to be careful here. Patch bounds, resolution -1, perfect. So I think we want to do number of steps like this, less than or equal, and then we, yeah, this is one issue with the current approach here. So in this method we transform a 2D index to a one-dimensional index, and then here we transform it back to a one-dimensional. So we want to fix that later on as well. I think we want both actually, because here we want it as one-dimensional, here we want it as two-dimensional, although yeah. So it's not called alter vertex data at index based on height map, it's called recalculate mesh data at index. XY. And actually, start index divided by resolution plus I. No, that's wrong, right? Shouldn't it be and that was a mess, and we want to do divide here. So X, we do row first. Yeah, so then we want to do it like this. Oh, actually, no. Why do you need both? It's easy to convert from 1dim to 2dim and the other way around. Yeah, probably. Like the current way we do it is that we do all the calculations in 2-dimensional indices. Then we change it to 1-dimensional indices. Then when we get out here, we use the 1-dimensional indices and we also convert back to 2-dimensional indices. So when we create a struct, we might as well keep the 2-dimensional indices and calculate the 1-dimensional indices, hence having both. But best case scenario, we only have one. We'll see about that. Rahim8x, thank you so much for the follow, appreciate it. Let's see here, am I thinking about this correctly? Start index divided by, or modulus resolution, I think so. And then divide by resolution. My homework is piling up, you know. Is this correct? You know what? I'm gonna be easy on myself since we're gonna have to debug this eventually. So we're gonna do start index oh yeah. So grid point indices range dot start point as index y, start point as index dot x plus I. And then set vertex buffer data. So the idea here, I mean, it might not be clear exactly what we're looking at, but the idea is to use this algorithm, which I always forget the name of, to get the points within a circle to hopefully skip X, changing X vertices data. It's a very optimistic optimization. I'm not even sure. We might just do it as a square, but we're gonna compare them later on and see how it works. But like, it basically comes down to, let's see if we can open up a nice little software called GIMP here. I want to refresh my own memory as well. So let's go with 16 times 16. Okay, so the idea is that, let's say we have our marker here. I'm not a big fan of this. Let's see. So, we have our marker. I don't even know if I'm getting a full square now, but we have our that's wrong. We have our marker here. And we want to apply a brush here. All the brushes, I think, they might vary actually, but the initial idea was that all brushes had a circular form. So when we do alteration on the terrain here, we alter the height maps within the square, so all pixels within the square. And we want to do it like that because it's going to be easier with the, hopefully we're going to do it on the GPU later on, so just easier to work with squares. I think. We don't want to put too much logic on the GPU. But then on the CPU side, when we need to update the vertices, in this example, we're gonna skip updating. So pretty much we're gonna skip 3 vertices in each corner, thanks to this algorithm. So we will only get the vertices within the circle that are where the center is within the circle. So we will skip 3 in each corner. So in this case, we do a hell of a lot of computation to just throw away 9 calculations, pretty much. But when we work with higher resolutions, like, there will come a point where hopefully the algorithm, like skipping updating the vertices without outside of the circle, becomes more efficient than updating all the vertices within the square. Like, this is the idea. I don't know. I want to try it. I want to see. So what we do right now is that we get this circle, we get a center point, and then we calculate like rows. So we get this row, so we get this pixel, this, or this vertex index, this vertex index, this vertex index, and this one. That's our first row. And then we get this to this as our second row, this to this as our third row, and so on. And then when we go through these rows, we go through them one by one to read the height map data, recalculate the normals and tangents in this case. So we do that for each value for each row. Or actually, it's more like this. So we start with this row, we recalculate the values for this vertex, or this vertex, this vertex, and this vertex, and this vertex. And then we take all of them, like we tell the mesh data that update the values of the vertices or the data at this index to this index in a big swoop. And we do that. Then we move on to the next row, do the same thing, and on it goes. And I'm still telling myself, like, there will come a point where this is more performant than also doing it for these, but I'm starting to doubt that. But learned something along the way. Okay, so that is basically what's happening here. So here we get the rows as grid point indices ranges. So each object within the list returned from this one is the rows with index data. Here we go through them and recalculate mesh data at indices, one after the other. Then this big swoop, we want to put this one outside of this for loop, but inside of this for loop, because here we do set vertex buffer data from this one, starting at this index for this one, or actually yes, so starting at this index within this mesh data, starting with at this index within this data, and going this many steps. And I wonder, I think we want to do this. And updating the mesh collider, that we want to wait with until the very end. So when we have updated all the rows, that's when we want to update the mesh collider and rebake it. I'm anticipating a couple of index errors here, but it shouldn't be too bad. Okay, let's see. And when we start testing with this, I'm going to lower the resolution of the... Okay, let's fix this first. Oh, yeah. Okay, so when we start testing this, I'm gonna lower the resolution once again. So we work with 128 times 128 for the full terrain. So I think it's 16 times 16 per patch. Okay, so terraforming does nothing and we get a lot of indices errors and stuff like that. Okay, here we go. Do we have a range of 256? 16 times... Yeah, we do. -8. Okay, that is not good. And I think I know why. I hope I know why. Also, yeah, here we clamp them. Actually, we clamp them here as well. So how the hell did we manage to get -8? We clamp them between bounds, and bounds is patch bounds, so 0 to 16, I think. But we never clamp the Y. But that's okay, because what a mess this is. Here we do bounds is value within range PY. And this one checks if we're within this, the bounds value. Interesting. Oh, did I clear it? Yes, I did. Bounds is value within range. Yeah, this one should remove negative Y indices and Y indices that are... Ooh. I might want to double check this one. Womb, thank you so much for the raid, appreciate it. Hope you had a wonderful stream. And welcome to all the new viewers. We're currently in terraforming, the terraforming swamp. We were talking about creature collecting game this morning, so I came here. Naturally. Unfortunately, there are no creatures to be seen here yet. So just to summarize, like this is a, if you know about the game called Viva Pinata, this is more of that, similar to that style of game as opposed to Pokemon. So the player gets a garden which he or she has to take care of, and depending on how he or she takes care of it, creatures will come and want to live in that garden. And what we're specifically doing now is we're doing the hard work of getting the garden terrain to work, because we want to support real-time terraforming. And yeah, it has been fun, but also extremely difficult. And thank you for the follow as well, appreciate it. Okay, let's try this again and just see what the... I want to keep the error message this time around, so I can hopefully deduce something from it. No Steam page yet. That is correct. This is pretty much the current state of the game. It's a little bit too early for a Steam page, I think. Okay, so here we don't get an error. Neither do we here. Interesting. Here we get an error though. So when we try to terraform this corner here, we get an error. And the worst part is index is -16. Right? Is out of range of 256 length. Yeah, the first devlog is quite a few years ago. I know. The actual first line of code was written 2.5 years ago, I think. And it's pretty much at the beginning of this year I actually started working, like putting more hours into it. But yeah, it takes time. Okay, index -16 is out of range 256 at 288. So the index we get from IJ here is out of bounds. And 122. Yeah, so it's one of these indices that are wrong. For sure. Enjoy that break. And thank you once again for the raid and the follow. Appreciate it. Factails, what's up? So, start point as index. One of these are wrong. We get negative values here. I wonder. I thought we had. Whoa. 1 sec. Nah. Okay. This one is 0 in either, I think it's Y actually, but in either X or Y. And what? 1 sec. Centered endpoint as index. Yeah, this is wrong. Is it origin as index? Yes, okay. So the idea was never to use these more than this one. We just do it here. Okay, I get it, I think. Or do I? Yeah, we have a big error here we need to take care of. Origin as index, centered endpoint as index. I should have gotten an error earlier here. Let's take a look. So P, we actually remove Yeah, we remove all the points that are outside of the bounds in the Y. But then for some reason we do origin as index plus centered endpoint as index. That's weird, isn't it? Let's see, we create grid point indices ranges, circle origin as index, and P. What the fuck are we doing that for? Yeah, what we should be doing here, I don't even know if we need this one. Oh yeah, we need it here, but we definitely don't need it here. I think we just want to do this. Centered endpoint. Yeah, this should definitely just be PY we use here. That's one issue, definitely. Because basically, once again, what we do here is that we get points in a circle, we get the rightmost points in a circle, and then we create grid point indices range. So we take the rightmost and we go to the left. But the Y should still be centered endpoint as index. I'm quite interested in why I named it centered endpoint, though. That was a bad decision. Points. We mirror them, order by py then px. Oh yeah. And here we order by p. Yeah, we definitely don't need to order them again. Hence this comment. But okay, everything tells me that centered endpoint here we just want this one here. Yeah, let's try it at least. Hopefully we won't get an error. Although I'm a little bit... So the error was like the biggest mistake, but we still didn't get any terraforming going here. So I wonder why. Okay, no errors. That's good. But we don't... Ooh. We do get a little bit of a terraform here. Yeah, we fucked up. The indices are not being calculated correctly. Okay, let's go through this one real quick. I want to check grid point indices range, circle origin as index, grid offset ZX, grid delta. We do the same thing here. Radius as index, we do the same thing there. Okay. Then we go through this very nice algorithm, and we have double checked these values multiple times, so I'm pretty sure this part is correct at least. But if it comes to that, we're gonna have to print these again, but it's okay. Mirror them, order them, just take the last ones for each row. Okay, what we're gonna do is we're gonna move back to terrain patch, because here we have a function that is get vertices within circle rect, and what we do here is origin in plane object space, inverse transform. Oh, no. I want to do this one. Here we do the exact same thing as we do down here, but here we return the vertices in question, and we do it by grid point indices range start index. Oh. Very interesting in this. So we're gonna take get vertices within circle, and we're gonna do Here we do get subarray start index. Okay, I'm okay with that. Number of steps. And then we get the object space vertices, we transform them to world space, and we do that for all the ranges, then we return the vertices. So what we can do then is go to action terraform and update marker, we call this one at all times. So we're gonna do so yeah, we don't do, yeah, might as well do this. So what we do here is we get all the terrain patches within a marker, and for each terrain patch we get all the terrain points that we're gonna alter. Whoa. Get vertices within circle rect. Yeah, here we want to send in okay. So the idea here is we just use the same approach, but when we get the vertices back, we place 3D objects on those positions. And just to see how it looks, hopefully that will help giving a clearer picture on what's actually going on. Hopefully without errors, but we'll see. Yeah, we can see here that it's kind of fucked. Actually, how many number of visualization points? Yeah, that might have something to do with it. Let's go with, I don't know, 200. Actually, when we look at it like this, it looks to be entirely correct. And if we put it here, between two patches, we get nothing wrong there. But actually, let's see. Never mind. Get vertices within circle rect. Yeah, that one uses the rect. We want to do get vertices within circle. Okay. Good. Now let's see. Okay, this is going to be more interesting. I think they will pretty much be all over the place, unfortunately. So the marker is located here, but yeah, we can see that our points are way over here. Why? Ooh, is this a simple problem of using column first when we have row first? Might be. Might be. Might very well be. One sec. Okie dokie. So where do we go wrong? Get vertices within circle. So this is when we get the sub-array. Add range. So we get sub-array here from grid point indices, range, start index, and number of steps. I think this is correct. Bounds should be correct. But okay, let's see if we can find the problem with row first. Start index. No, we're not doing it wrong here, I don't think. We're gonna double check. Shitty Games or Shady Games, thank you so much for the follow, appreciate it. Double check. We do it the y times resolution x. Yes. Plus x. Origin as, yeah, okay, we're using origin here, which if I'm going to be entirely honest, I don't know why. Yeah, this is wrong. Definitely. We don't care about origin here. We have an endpoint, that should be enough. And the endpoint is, so minus here should be Okay, so the idea here is that we have an endpoint. So we draw our circle and then we calculate endpoints for this circle. So here it would probably be this pixel, that is the endpoint. Here it would be this pixel. The idea then is that we want to get the opposite point of that one, so the start pixel, but to get the opposite point of the end, we need to have the relative point of the middle pixel, so we know like how far from the center, because it's not centered around 0. So okay, that's the issue. So what we want here is, let's see here. I think we could do number of steps is equal to 2 times centered endpoint as index minus origin as index. That's the number of steps. And let's just keep this one down here to make sure. Oh yeah, we want to do .x and .x. So doing this gives us the number of steps from the center to the endpoint. And we times 2 because we want that should be it. So now we have number of steps here. So what we should be able to do here is, are we gonna get rounding errors if we do this? Let's try it and see what happens. So origin as index minus 0.5 times number of steps. And we want to do the same thing down here. I don't know what the hell I was doing here. We already have the endpoint, but centered endpoint. What was I thinking? Yeah, ooh, I know. Yeah, now I'm screwing things up. Okay, let's take one step back. So, this is it. Now I'm on the same page as I was when I implemented this, I hope. What we have here, what we're working with here, are points centered around origin. So that is why we have centered in the name. Which also unfortunately means that we take origin as index, that this should be correct, but okay, I get it. And that's why we did this as well. So we offset the points from the origin after we have mirrored them. Very important. But this line here, so we create these indices, but what this means is that we unfortunately need to do this one here. So up to this point we are only working with y values that are centered around the origin, but down here we don't. And here we actually have an R, we have a range, so bound is value within range, and here we do R dot start index, start point as index dot y. There's a lot happening here, so let's see if we can go through it and make sense of it before we try it. We have a circle origin here, we have a circle radius. We create circle origin as index, but we don't do anything with it until here. So we only work with the radius, or radius as index, moving on here. And we get all the points for the first octant in the circle around origo. And when we have that octant, we mirror it, and then we mirror it once more here to get the start points. So after this step, we have a set of points around origo on the right hand side of the circle. Here we create ranges from them, so now we actually have all the points if you want to look at it like that. And within this one we also offset the points based on circle origin. Offsetting them might lead to y values of the indices being negative, and we want to filter those out. So we do that here. And then we make it into an array and return it. Centered. Okay, so that was a good variable name from me. But yeah. Let's try it, see what we have, and try and figure out why it's not working or if anything is wrong. We're still a tiny bit off, but a tiny bit off. We're far off, but not as bad. Do we have the correct number at least? Yeah, I think so. Actually, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Could it be? Could it be? Yeah, I think we have a simple offset by 1. Thanks to... Yes. Thanks to this one, I think. maybe. Actually, something like that at least. It has to be. It looks like we have an offset. Yeah. But the only point I see this where this mistake could be done is down here. But this seems to check out. Unless, of course, bounce is wrong, but I don't think so. So what if, for instance, if we would be to do, if we would do dot number of steps. I think we want one of those. Oh yeah, dot. Ooh. Yeah, dot position. Right. Actually, down here, dot position, and then we do transform dot position. Although that should be okay. So here we rely on start point as index. Here we rely on terrain patch index instead of the indices generated in the range itself. I think we will see a similar result as we previously had. Do we? No. We actually see the correct result. Is that so? Here we get some extra points, but I guess that's okay. So the points here are would like to be able to remove those as well. So this one and this one. But at least we get the correct points, and we do get it. Ooh. Yeah, we're going one less, it seems like. Than we want. One less there at least. And here. And here and here. Is that a rounding? Okay, so it's not 100%, but I think this is something wrong with the indices creation. And not when we actually get the index. I wonder why. I'm gonna have to take a closer look. But okay, this works, although the ranges are a little bit fucked. I'm most disturbed by this one, to be honest. Like here we get this point, but not this point. One step closer at least. One step. So what could be the cause for this one? When we calculate the right hand side, we get this one. Or we only get this one. Rounding error, maybe. Do we get the correct ones in the middle of a patch? Yes, we do. So the no. We don't. We get symmetry at least. Would have been extremely weird if we didn't even get that. Although I wonder. Sphere radius. Terraform point radius 4.2. 4.2 to 8.4. What do we have here? Local scale. Is the radius error already included? If so, so we have a terraform point radius 4.2 plus 1.066667 times 2. Yes. Yep. Okay. So 8.4. This is the actual sphere we have, and that makes much more sense. Beautiful. This is exactly what we want to see. Still though, Ayo. Looks correct. But if we go, what was it, 10.5, 10.5. And then 8.4. Oh yeah, now we're right in the middle between two patches. So if we're in the middle between two patches, we get the correct vertices, indices as well. What if we are here? Looks correct, I think. Ooh. Definitely want to skip that, but I think I know the issue of that one. It's only on the X. Yeah, that makes sense. Or on the Z. That makes sense. Makes sense. Yeah, we have it in both direction on X. Okay, that makes sense. I think we can fix this. Everything else seems to work. I wonder why. Didn't look like it was working first, or actually, yeah, but because then again we only have 6.6. The radius is, we have an error margin, but what do we have it? Radius 2.23, 4.46. This looks amazing. This, not so much, but this is the same result same error we had with the rectangle. So basically we have index ranges, or index ranges, which both a start point and an end point outside of the patch, I think. Something like that. So basically we get, let's see here, we try to get vertices within the circle for this terrain patch, but origin minus radius and origin plus radius are both outside of it, and we do 0 less than or equal to number of steps. So when we return indices or ranges of indices, they start at 0, but they only have a length of 0. So I think we're gonna have to do something similar to as we did previously. Grid points together, so it's, yeah, if start point as index and end point as index are both, what we could do, like, I want to check if this works. It's an ugly hack, but, or actually, can I do it like that? Basically, we could do if what it comes down to is if I want to double, I'm just going to implement this in a rough way, see if this is the problem. So bounce.is value within range, much like we did previously. We want to check this value, if this value or this value, if one of them, let's see, yeah, if both of these are outside of the range, so we can do number of steps, else number of steps -1. Which means that's a number of steps -1. That means when we go here, we start with I is equal to 0, and then we do while I is less than or equal to number of steps. So we're gonna fail this one from the get-go, and we will return an empty array. And that will be that. Hopefully we will avoid this column here. Although I thought I saw some weirder behavior previously. Yes. I think it looks about right now. We don't get any overlaps, but dude, I want to implement this in a cleaner way. This is very nice. And basically, the bigger our circle is, the less vertices we throw away. Or the bigger the circle is, the more vertices we throw away, and hopefully make it more optimized. But I'm still... We'll see. We'll see. Okay, that's for that patch, and then we start for this patch, then we start at the next patch, and we go through these. Love it. Although oh yeah, we have... Ooh, I'm a little bit worried about this one. Or actually, no, I'm not. Never mind. And then we have... this is actually 3 patches. So this patch, and this patch. Okay, great. Okay, so now we have it up and running again. It was mostly okay. I just fucked some minor things up. Very nice. Although now we have to... So, definitely need a cleaner way to solve this problem here. And I don't think we don't know about this until we have created this grid point indices range. Like, this one might be outside the bounds, but the mirrored the start point as index might be inbounds. So we need both of these before we can check this, and would love to have them unclamped. And this is not a good way to do it, so but then again, I'm gonna have to rely on some similar solution as previous, like for a rectangle. And I'm also thinking about, I wonder if, like, I would love to be able to reuse terraform data. Because we could just check, like, if is within bounds for a square returns false, we know that it will return false for those rows as well. The problem is when we do the terraforming, we actually need to do it in two separate passes. So first we update all the height maps, then we recalculate the vertex data. So you do want to have these split up. Because we need to sync, like, some of these recalculations might need information from their neighbor's height map, so we just want to make sure that that one is updated. In the future, however, let's see. Yeah, I don't know if you want to, like, cache that information and reuse it, but if you want to cache it, who's going to be the owner of it? Like, who's going to hold it? A lot of problems. Oh fuck, you could do something. Like, you could, you could, like, pass the ownership over to this action terraform, because the terrain patches maybe shouldn't know this much. So, like, we have an action terraform, we have a terraform data, but, like, I wonder if we want to have an action terraform data which stores terraform data. So the first thing you do here is that you poll, when we do an action terraform, we pull the information from each terrain patch, and then we loop through them. Then we have that information for each terrain patch, and that information tells this action terraformer like which patches should be affected by this, which vertices for each patch should be affected by this, and which vertices are within the circle. Maybe we could do something nice like that. So when actually doing the terraform action, you first pull all this information from the terrain patches, and then you use that information to tell the terrain patches how they should alter. Maybe that's a nice way to have it. So then you would rely on two methods like apply terraform action to height map and apply terraform action to vertices. Something to think about at least, because now I unfortunately got to run. But love the progress today. We'll be back tomorrow. Keep bashing my head against this terrain and terraform stuff, but yeah, it will be fun. So thank you so much for watching, everybody, and have a great rest of the day. Peace.